All right, guys. Sorry I couldn't be there today. So I'm gonna go ahead and go over the 4-3 notes with you all. We're gonna just kind of pick and choose. I'm not gonna do all of them because I wanted you to do some on your own. But it should give you an idea. So this lesson, as long as you guys can factor, it's really not that difficult. All right. But factoring is the more difficult part for this. So just to kind of give you an example, what we're going to be doing, a rational expression, it's the quotient of two polynomials. So you take two polynomials, put them over top of each other, and that's a rational expression. The domain is all of the real numbers except for those for which make the denominator 0. Okay, and we're going to talk about that here. So first, just to kind of give you an example. So you guys have been reducing and simplifying fractions your whole life, right? But just to kind of see how it works here, if I take 12, right, and I write it as a product of all of its prime numbers. Okay, so 12, for instance, can be rewritten as 2 times 2 times 3. Right, 2 times 2 is 4, times 3 is 12. 16 can be written as 2 times 2 times 2 times 2. Okay, now, when we reduce this, you guys know, for instance, that this can be divided by 4, that can be divided by 4, so it's ultimately going to be 3/4. But we can do that because when we group common factors, so for instance, 2 divided by 2, this becomes 1, right, times 2 times 3, and then you have 2, 2, and 2. Over here, you group another one, you end up with 1 times 1 times 3 over 2 times 2. Okay? And the reason you can do that is because 2 divided by 2 is 1. So ultimately what we end up with is 1 times 3 over 4, which is just 3/4. Okay? So you reduce the fraction by saying 3/4. Now, we can also reduce rational expressions where we have polynomials. Okay, not quite as nice as this down to 3/4. Sometimes it does, but not always. So when we do this, okay, what we're looking for is we're looking for common factors, just like we do here when I'm looking for 2 over 2. So what we want to do first and foremost, okay, is we're just going to factor as much as we can. So for problem B, I'm going to first look for our greatest common factor. Okay, so first I'm going to take out an x of both the numerator and the denominator. Okay, they both had a GCF of x, so I take it out. Okay, next, right, I'm going to factor the quadratic. Okay, so I'm going to carry down the GCF, and x squared minus 5x minus 24 factors to x minus 8, and x plus 3. The denominator is going to factor to x plus 9, x minus 8. Okay, so what we're looking for now, okay, is we are looking for common factors, right? And those common factors are going to cancel. So here, my x's cancel. The x minus 8 and the x minus 8, those are common factors. Those are going to cancel out. And so we end up with an x plus 3 over x plus 9. This is your simplified reduced fraction. Okay. But one of the things that we always want to include when we talk about simplifying rational expressions is we always want to talk about the domain and what its restrictions are. Okay, so when we have fractions, remember we talked about how you can never have a denominator of 0. So this is our simplified fraction only when x does not equal -9. Okay, but we also have to include the values that we canceled out. So for instance, x can't be 0 because that would make this a 0, and it also can't be 8. Right? So our solution is x plus 3 over x plus 9 when x does not equal -9, 0, and 8. Okay. All right, let's look at a couple more simplifying, and then we'll take a look at multiplying and dividing as well. Okay. So for C, I'm going to go ahead and take out a GCF. So 3x to the 5th minus 18x to the 4th minus 21x to the 3rd looks like it's 3x to the 3rd. All right, I take that out and I end up with x squared minus 6x minus 7 in the numerator. The denominator, we have a GCF of 2x to the 4th, and I end up with x squared minus 49. Okay. We continue to factor. Okay, I'm going to bring down my GCFs. The numerator factors to x minus 7, x plus 1. the denominator to 2x to the fourth. It's a difference of perfect squares, so x minus 7, x plus 7. Okay, so from here, once we factor everything out, we're going to look for common factors that we can cancel out. Okay, so the x minus 7 and the x minus 7, those cancel. These do not. Those are not same factors. However, when we look at these expressions right here, right, 3 over 2, that does not reduce. So we can go ahead and bring that down. But x to the third and x to the fourth, we're dividing these terms and they have a common base. So we can subtract those exponents and I'll just end up with x in the denominator. Then we still have the x plus 1 in the numerator and the x plus 7 in the denominator. So this is as simplified as it can get, but this is only true when x does not equal 0, -7, and then also 7 from the one that we originally canceled out. Okay? All right, let's see which other ones I wanted to look at. Let's go ahead and take a look at D, and that'll be enough for simplifying. Okay. All right, so one of the things I wanted to do with D is notice that in the numerator you have 4 minus x squared. So one of the things that's always helpful when you're simplifying, okay, is to go ahead and make sure that all of your problems are written in standard form. So even if you recognize that this is a difference of perfect squares, it's going to make it easier when you factor if you go ahead and rewrite this as a negative x squared plus 4. Right? And so what you're going to do now is anytime this first one's a negative, I'm going to go ahead and factor out a -1. Okay, and it'll make it easier down the road if we write it first in standard form, and if your first term's negative, factor out a -1. And all that does is just change the signs of all of these right here. Okay, so I factor out the -1. Now I'm going to go ahead and factor out the rest of it. So x squared minus 4 is x minus 2, x plus 2. The denominator is x plus 5, x minus 2. Okay, so common factors. We've got x minus 2's that cancel. So in the numerator, we're left with a -1 times x plus 2. The denominator, we're left with x plus 5. Okay, but this is only true when x does not equal. Okay, a -5 would make this 0, and then the 2 from the canceled out one would make that 0. Okay. So this right here is your final answer. Okay, and ultimately you could probably redistribute the negative to make that a -x minus 2, but that's just as good. All right, so that is simplifying. If you are good with factoring and recognizing that you cancel out common factors, okay, then the rest of what we're going to be doing is easy as well. So let's go ahead and take a look at, next page, take a look at some multiplying. Right? So when we multiply fractions, right, to multiply two rational expressions, follow similar steps that you would follow multiplying numerical fractions. Multiply the numerator and denominator, and then simplify your fraction. So for A, okay, we're going to multiply straight across the numerator. So I've got 2xy times 3x squared. So I'm going to go ahead and multiply the 2 and the 3 to get 6. The x's, I've got x to the first and x to the second, which are going to give me x to the third, and then y. The denominator, I only have the 4 as my integer, and I have the 1y, and then I have 2z, so that gives me z squared. Okay, so we're going to multiply, and then we're going to simplify the fraction. So 6 over 4 simplifies to 3 over 2. X to the third, I don't have any x's in the denominator, so that's going to stay. My y, I've got a y and a y, those are going to cancel. And then we've got z squared. Okay. That's your answer. Okay. All right. Let's take a look at B. Okay. So here, okay, we've got multiple terms here. So what I'm going to do is I'm going to go ahead and just draw a fraction bar out. Okay, so we're going to ultimately multiply all the way across. But rather than actually multiplying it by distributing the 5x and everything, I'm just going to go ahead and write all of my expressions written in factored form, okay, down here on this fraction bar. So we've got 5x, x squared plus 5x minus 6 factors to x plus 3 and x minus 2. And then x squared plus x, that has a GCF of an x, so we're going to say times x plus 1. Okay, so ultimately I'm multiplying those all the way across, right? So this is just one big expression. All of those are being multiplied, but they are in factored form. Then we're going to do the denominator. I've got x plus 3, x squared plus 2x plus 1 factors x plus 1 times x plus 1. And here we've got a GCF of 5, so I'm going to factor out the 5, and I get x minus 2. Okay? So we multiply across, then we look for common factors. Here I've got x minus 2. We've got x plus 3. I've got x plus 1. Right? And so this is 5 times x. So 5 and x are actually different factors. So 5 and 5 right here will cancel. And so we're left with x times x in the numerator and x plus 1 in the denominator. So I end up with x squared over x plus 1 only when x does not equal a negative 3, a negative 1, which is the same here, and 2. Okay. That's your answer. So factor them all out, put them on the same line, cancel out your common factors. All right, we're going to go ahead and skip C because C is similar to B. Let's take a look at D. All right, and if I'm going too fast, then you need to just ask the sub to pause so you guys can catch up, catch your breath or whatever. All right, for D. Okay, so similar situation, but keep in mind the second fraction where it's not an actual fraction, just think of it as everything being over 1. Okay, so we're going to multiply it all out, but as I multiply it, I'm going to factor it. So I'm actually going to pull them apart rather than multiplying it all the way out through. So this one, before I want to go and factor out the GCF up here. I got x squared plus 4x minus 12. And so that way I can go ahead and put the fully factored form down here. So I bring down the GCF. All right, then I get x plus 6, x minus 2. The denominator, right? So x to the 4th minus 16, all right? I do notice that this is a difference of perfect squares, and it factors to x squared minus 4, x squared plus 4. The reason why I rewrote it right here is because I recognize that x squared minus 4 is actually going to factor again to x plus 2 and x minus 2, because this is a difference of perfect squares. X squared plus 4 is not a difference of perfect squares, so it doesn't factor further, right? I know we talked about factoring the sum of squares using imaginary numbers, but we're not going to do that in this unit. Okay. So here, once we've fully factored everything out, we're going to look for common factors. So my x plus 2's cancel. I've got an x minus 2 and x minus 2. And I've got an x, no other single x down here, x plus 6, no x plus 6. So we end up with x times x plus 6 over x squared plus 4. Okay? But this is only true when x is not negative 2 or 2. This right here, x squared plus 4, if you were to solve and set it equal to 0, all right, so we say, all right, well, what would make this expression equal to 0? You get x squared equals a negative 4, you take the square root, and you end up with imaginary numbers, right? And so we don't have to exclude imaginary numbers from our domain. We're just talking about the real numbers. So the only numbers we need to exclude are the negative 2 and the 2. All right. You want to get fancy and exclude positive negative 2i, then by all means go ahead, but it's not necessary. Okay. All right, let's take a look at F. Okay, so taking a look at F. One more problem just like this, just to give you an extra example here. So once again, this expression, we're going to pretend it's over 1. All right, I'm going to draw my fraction bar. 5 and a. So it doesn't factor, but if you want to write it as two separate terms as 5 times a, that's fine, just so that way you can see the separation. 10a plus 10 has a GCF of 10. So I'm going to say I'm going to factor out a 10, and I get a plus 1. Okay. The denominator, all I have is 5a plus 5, so it has a GCF of 5. We take that out, and we have a plus 1. So in this one, the 5's are going to cancel, and the a plus 1's are going to cancel. So we are left with 10a when a does not equal negative 1. Okay. All right, so that's multiplying. Make one big fraction bar, factor out all of your expressions, put them on a single line, cancel out your common factors. Okay. Which leads us to division. Okay, which once again, okay, division is very similar. Okay, but to divide rational expressions, remember you multiply by the reciprocal of the divisor. Okay, so here we have x squared plus 2x plus 1 divided by 1 minus x squared divided by x squared plus 5x plus 4 over x squared plus 3x minus 4. So this is the same. I'm going to go ahead and rewrite this in standard form as a negative x squared plus 1 as multiplying by the reciprocal. So once you take that second fraction and you flip it, then it becomes a multiplication problem, exactly like we were just doing before. So none of them have a GCF except for this one, so I'm just going to go ahead and factor the GCF of a negative 1 out right here. All right, so that way I can factor them all and they're fully formed as we go down. So the first fraction, this is x plus 1, x plus 1. The second one, we get x plus 4, x minus 1. Here we've got a negative 1. We're going to bring down that GCF. X squared minus 1 is the difference of perfect squares, so x minus 1, x plus 1. And then here we have x plus 4, x plus 1. Okay. So now we're going to look for common factors. We've got x plus 1, x plus 1, x plus 4, x plus 4, x plus 1, x plus 1, x minus 1, x minus 1. So this is probably my favorite problem we'll do all year. I just love canceling out all the terms like that. But either way, okay. There's nothing left up in the numerator, so we got to leave a 1. The only thing we have left in the denominator is a negative 1. So our answer is negative 1, but only when x does not equal 1, negative 1, negative 4, and that would be negative 1, which we already have. Okay? Is that okay? Good. All right. Let's take a look at, we're going to do both B and C, okay, and then you guys can work some on your own. So for B, okay, so we're dividing. So I'm going to go ahead, as I work this out, I'm going to go ahead and factor it. So the numerator, I only have 1. The numerator here, so remember we're flipping this. So in the numerator, I'm going to have this right here is going to be my numerator, 3x times x minus 6. The denominator, right? So this one right here, it's not in standard form, so I'm going to rewrite this as negative x plus 6. So in our denominator, we have x squared plus 9x. I'm going to factor out an x. Right? Here, once I wrote that in standard form, we can factor out a negative 1. Okay. Now, it's important that if we did not factor out that negative 1, then we wouldn't be able to cancel out these x plus 6's. Okay, so it's important that you recognize that when it's not in standard form, rewrite it, and if the first term is negative, take out that GCF. Okay, so that way you can cancel out those common factors. All right. Then here we've got an x and an x. Those cancel. And so we're left with 1 times 3 in the numerator. The denominator, we're left with the negative 1 times x plus 9. Okay, now, this is correct. A lot of times when you have answers written like this, they will transfer the negative up to the numerator. So you might see it written as negative 3 over x plus 9, and that's okay. All right. So negative 3 over x plus 9 when x is not. Okay. Now, for actually, I think it's okay for this one because it worked out. When we talk about division, we want to use the original problem. Okay, so when we think about what would make this equal to 0, it was 0 and negative 9. But what would make this equal to 0 it was 6. So x can't be 0, -9, or 6. So you want to use it before you multiply by the reciprocal. Okay. All right, we'll do one more problem, and you guys got the rest of the class to kind of to practice simplifying, multiplying, and dividing rational expressions. Okay. So the last problem here says we have a parallelogram, okay, with an area of 3x plus 12 square units, and it has a height that is shown. Find the length of the base of the parallelogram. So don't remember from geometry, to find the area of a parallelogram, you take the base times the height. Okay. So the area is equal to the base times the height. We know that the area is 3x plus 12 over 10x plus 25. Okay. We don't know the base. We do know the height is x plus 4 over 2x plus 5. So if we want to find the base, we need to divide, okay, by this expression. So the base is going to be equal to 3x plus 12 over 10x plus 25 divided by x plus 4 over 2x plus 5. Right? So when we divide, we multiply by the reciprocal. So it's going to be 3x plus 12 over 10x plus 25 times 2x plus 5 over x plus 4. Okay, we flip the second fraction. This equals the base. Okay, so when we multiply, I'm going to factor. This has a GCF of 3. Okay, 2x plus 5 does not have a factor, so I'm just going to go ahead and put in parentheses. Okay, 10x plus 25 has a GCF of 5, so I end up with 2x plus 5. X plus 4 does not have a GCF, so I'm going to write it down here in parentheses. So we look for common factors. I've got x plus 4 and x plus 4, 2x plus 5, 2x plus 5. We're left with 3 over 5. So our base is equal to 3/5 in this problem. Okay. All right, that's it for your notes here. You guys, I want you to do the additional practice. And then I've got the answers already up around the room for you to check your work. Once you finish with that, you're going to turn that in and then get the adventure puzzle worksheet from the sub. All right, you guys have a good day.